Hi everyone, my name is Leonard and welcome to Datature Tutorials. Today we're going to be training a video classification model. The goal of video classification models in general is to assign categories to videos based on the visual content in the frames. In this particular project, we want to assign categories based on the sport that's being played within the videos. To get started with this project on Nexus, the first thing we want to do is upload the videos and relevant data onto the platform. So we'll get started by going to the dataset page and uploading our data there. There's a few ways to upload data onto the platform, either by uploading assets in that rectangular box there or through external buckets. As you can see, we've already uploaded 1,441 assets into the project already, so we can go right ahead to the next step, which is the annotator, as we want to annotate each of these videos with the correct category for the model to learn. So we'll filter out so that we can find the asset that has been unannotated, which is this video right here. And we'll play the video to see what the category should be. Based on the video, it seems like a wall push-up. So what we'll do is go ahead and click the wall push-up tag on the right panel there, and then we'll want to annotate each of the frames accordingly. To do that, what we would want to do is click on interpolation mode, as this will allow us to mass annotate all the frames together, as opposed to having to click through each of the individual frames with the relevant tag. So to use interpolation mode, what you have to do is to annotate the first frame. So we can press A to assign that first frame, and then we can go to the last frame or whatever frame you want to end up at and assign that same label. And you can see that across all the frames within the video, each of these frames have been assigned with the wall pushup label. And then we can commit these annotations and they're now saved onto the project. And we can exit interpolation mode and see that every frame in this asset has been annotated. When we unselect the filter, we can see that there are quite a number of assets that are already annotated, which means that our training dataset is ready for the actual training itself. So in order to get started with that process, we'll go back to the project page and navigate to the workflow page on the left panel there. And we'll go ahead and create a workflow. So we'll opt to build my own workflow instead and create our own custom workflow based on our necessary requirements. We can right click and create a dataset block and then customize that dataset block with whatever hyperparameters are available. We can then also create a model block. In this case, we are going to choose the largest model, MoviNet A5, which is the most robust and most highly accurate model there, given the number of categories that we have and our use case. Compared to image classification, there are a number of new training parameters that can be modified within this model block relative to other model blocks. Batch size will be a familiar parameter, which is the number of images or frames being processed at once. But the frame size is unique. Frame size is essentially how many frames are being used by the model to determine the action that's taken. So in this case, we might modify it to 20 to expand that context window. Frame stride is also a new parameter, and this is to basically describe how frequently we're sampling these sub videos or from the original training dataset. So a frame stride of 1 would mean that the model might take frames 1 to 20 as one sub video to learn from, and then it would move to 2 to 21, 3 to 22, etc. The discard threshold essentially describes whether we want to use a video if there are fewer than a certain number of frames relative to that initial frame size. So segments which only have 2 to 3 frames would be discarded based on a 0.5 threshold. We can also modify the training steps to 10,000 to increase the accuracy and train longer on our large dataset. Once we're happy with the model, we can select run training and apply these various hyperparameters in terms of the advanced settings and hardware configuration so that we're learning with the highest accuracy and running on the necessary compute. Once we're happy with these settings, we can select next and start our training. We'll now jump to a training that is already completed. And as we can see from this completed training, we will be able to see the live dashboard, which contains typical loss metrics for a classification model. As we can see from the precision and recall graphs, this model has learned quite well and seems to be highly performant. We can also look at the advanced evaluation tab, which is a visual reference for how the model has performed. And we can see that over the course of the different evaluation checkpoints, the model has gradually learned how to classify the frames correctly. We can also see from the confusion matrix uh, how each of the individual categories are performing, and we can see that largely all the categories are performing well, except for rowing, which is not 100%, but essentially performant. Now that we're happy with this model training, given the strong results, we can go ahead to artifacts to export or create a deployment for our model in production. In this case, we might want to opt to export the artifact so that we can download it and run it on our own device. And as you can see, we provide several frameworks for that, such as TensorFlow, TF-Lite, etc. Now we'll be able to download our video classification model and be able to run it on various sports videos and be able to automatically classify those videos.